Okay, just a little review here. Don't write any of this down. A representative example of all the different types we've seen so far, and then we're going to do the last one, all right, which is already written in over there, but I'll explain what it means in a minute. Okay. Just a quick example of each one. First of all, if I gave you this guy, again, don't write, just look. Cu2s. Can you tell me what his name is? Based on what we've learned over the last couple of days, I would hope everybody can. But there's a small little mistake people make on this one. That's why I gave you this guy. You might want to have your common ion sheets in front of you in order to do this. You're going to need them anyway in a minute anyway, so get them out. So get those. Anybody not have a common ion sheet yet? Anybody absent yesterday? Didn't get one. Here you go. Anybody else missing a common ion sheet? Okay. So what do you think Cu2S is? What do you think?
Copper 1 sulfide.
Good. He remembered you have to use, for most of the guys that are in the middle, they're going to have Roman numerals next to them. Not all of them, but most of them. So copper 1 sulfide is a good answer. Okay? It's a binary compound. You classify these first and foremost. Is he binary? If he's binary, he's going to end in "ide," no matter what. Okay? We know that from simple ones like sodium chloride. Everybody knows how to call salt sodium chloride. Okay, now another one. Try this guy. Now, notice the difference here for this guy when you go to name him. He's still a binary compound, just like sodium chloride, just like copper 1 sulfide. But I have to do something different here, Becca. What do I have to do?
You have to add prefixes.
I have to add prefixes in front of these guys. So I'm not going to call him sulfur oxide. I'm going to call him what? Disulfur pentoxide. All right? And this is all from yesterday, day before, whenever we first got this. I forget. You got a double yesterday. You probably got them both yesterday, right? Okay. So those of you, if anybody's absent, I think Ronnie at least was absent. Anybody else absent yesterday? You basically should have watched the thing. Probably didn't. I'm going over it now. And by tomorrow, you better have it down. All right, let's do another one. We also got this, say I gave you calcium nitride. This one's got a neat little twist to them too. I want you to write the correct formula for calcium nitride. It's not enough to just write Ca and N. Because what do I have to use? The what? Yeah, I got to use the charges. The charges are what tells me what the subscripts are going to be. Charge on calcium, +2. Charge on nitrogen, -3, right? Okay, so the correct formula, again, this one also chose for a reason. There's no one number to just use here. I've got to have to use a 3 there and a 2 there, right? That'll balance them out. So I've got 3 times 2 is a +6, 2 times -3 is a -6. Because remember what the charges really mean. How many electrons are lost or gained, and they have to be equaled out, as we saw in the last test. Last one of a review now. Just got yesterday also at the very end a guy like this. MgNO3-2. Now that is not a binary compound. Everybody else up here, I just wrote binary, and you know it because he ended in "ide, and you know it because it had only 2 elements. But this guy has 3. He is not magnesium nitride. What is he?
Magnesium nitrate.
Magnesium nitrate. Now notice I did not use the any prefixes in these cases. I don't call it dinitrate, just magnesium nitrate. Got it? Now, what I told you there was a 4th problem I was going to give you today. And you'll have the rest of the period. After I give you this 4th thing, you'll have the rest of the period to finish up and complete your homework. I am checking the homework tomorrow. All that's up here has to be done. Okay? I've given you some time in class. A little bit of time at the end of the first period yesterday, a little bit of time at the end of the period at the second period, and then you're going to have a lot of time today because it won't take me very long. But the other problem is, if you look at your common ion sheet, it turns out that these guys that are on the sheet, those negative polyatomic ions, there's a lot of different forms of them. It's not just the one on the sheet. That's what I got to go over with you. Take a look at your sheet. What's chlorate say on the sheet? What is the formula for chlorate ion? ClO3, y'all see it on there? Y'all see it? So if I have, look here, if I had KClO3, you all agree that would be potassium chlorate, right? Okay. Here's the problem. Make this chart. Turns out there's more than just the one that's on the sheet, the root word. I'm going to call that the root word. That's my own little knowledge, right? My own little terminology, I should say. That's the guy that's on the sheet, ClO3. But look at the other versions I could have of that ion. Just by changing the number of oxygens, I can have ClO2, ClO, and ClO4. Copy all of those down, and I'll tell you how we name them. Won't take me very long, and that's all the notes I have. I'm going to spend the rest of my time just doing examples. So copy all those down. These guys are not on the sheet, but they're all named the same way. And a lot of those guys could have different numbers of oxygens. A lot of the guys on those sheets, like for example, there's an NO3 on the sheet. It could be NO4. It could be NO2. I could do that. All right? So, let's go over how we name each of these. Everybody knows how to name the first one. What's he called? No. There's no sodium in front of it. Just chlorate. This is the chlorate ion. And underline the ATE. That's what's going to change, the suffix. By the way, good point, though, what Marvin said there. Watch. Technically, the way it's written right now, this is chlorine trioxide, chlorine dioxide. I'm assuming you realize I'm just writing the ion. All right, so really it should look like this. Don't do it, but I'm just saying that's what we're really writing here is the ion. Because really, you could have had sodium in front of that, be sodium chlorate. All right, so we're not talking about the compound ClO3, but rather the ion. Now, what would the ClO2 ion be called? He would be called chlorite. So I just changed the suffix to ite instead of ate. I'm going to go off on a little tangent for this next one. The next guy's called, he has 2 less oxygens than root word, 1 less than chlorite. He's called hypochlorite. Who can tell me why that makes sense? Who can explain to me how you would have known that would be, you can remember that that's hypochlorite. Have you heard the prefix hypo before? Give me some common words, not just biology. First time I ask this in every class, they always want to tell me hypotonic. I'm not talking about other bio terms you memorize. I'm talking about in everyday life. Where have you used the prefix hypo? What's that? Hypotenuse. Oh, good. I didn't even think about that. But that's, again, I don't use that in everyday use. That's a math term. Everyday use. Every day you use these terms. Come on. Say it. Somebody? Karen, you're saying something over there. What? Hypochondriac, I think you're thinking of.
Yeah.
Hypochondriac. You ever heard one? What's a hypochondriac? Thinks he's always sick, right? So his health is poor. Poor person in poor health. How about for suntan lotion? What does it always say on them? Hypoallergenic. What kind of a needle you have? What kind of a needle do you get? Hypodermic. See, these are actual words. They're not just math or biology words. They're real words. Somebody's cold, dies from being too cold. Hypothermia. These are real words. And in every case, see what I'm doing here? It's an amazing thing. I asked you, and like everybody's just looking at me. I don't know. The only thing I can think of, the only thing anybody ever thinks of are science terms, like hypotonic, math term, hypotenuse. No. You have to apply things to stuff you already know. That's how you take your SATs. You're not going to know every vocab word. I wouldn't know every vocab word, and I'm much better read than you. Mr. Calarco probably wouldn't know every vocab word. He teaches English. So you have to use a little common sense. You have to say, oh, where have I heard that before? Hypothermia means what? Hypothermia. Cold, lower temperature, right? Hypodermic needle goes where? Under the dermis. Hypoallergenic means less allergenic, right? So what does hypo mean? Less. And that's why you're going to remember that hypochlorite is less than chlorite. 1 less in this case, oxygen. And what's the opposite of hypo? Hyperactive, right? perchlorate is that guy. Now, I know it seems like a lot of time to go off on a tangent like that, but remember, the tangents are more important than the actual chemistry because very few of you are going to major in chemistry, but everyone's going to major in tangents. Not really.
No.
The point is, the other stuff you can use other places. No one's going to ask you what hypochlorite's formula is if you don't become a science major, okay, if you don't have to take science again. All right? But hypo, that's going to pop up all over the place, and you should be able to know what that word means, or that prefix means. All right, good enough. That is the end of the notes, but we have a lot of examples to do to practice this. So these are all the different versions of that ion I can have. Oops, sorry. Let's do my examples. First one. K2SO3.
Are you okay?
I'm okay. K2SO3. I'm noticing Marvin's is doing this, and some other people do too. Don't use cursive for these. I normally want you, when you're taking notes, I don't mind you write. I like you to write in cursive. But when writing formulas for it does get, if you write K, people write their S's weird. I mean, don't do that. It'll look like a G. A G is, you can't, don't do that. Just use capital stencil type letters, okay, or lowercase, because that makes it very difficult. All right, look at that. That looks like G-O. I mean, it really doesn't look like an S. Anyway, what do you think this guy is?
Potassium.
Potassium. Yeah, everybody get an answer for themselves in your head if you haven't by now. And what do you think? He is?
Sulfate.
Well, this would be potassium sulfate. Is that what that is?
No.
Potassium sulfite.
Wait, why? I have 3.
Good mistake. Gotta like Emily. She has no problem making mistakes. And that's good. She thought I said a minute ago that, and I never did, I have the video to prove it, every time it's 3, it's 8. Every time it's 2, it's I. Every time it's 1, it's hypo. And every time it's, did I ever say that? I said less than the root word. Less than the root word. Less than the one that's on the sheet. And the one that's on the sheet isn't the same every time. What one's on the sheet for this guy? 4. This guy's got 1 less than the root word on the sheet, which is why this is potassium sulfite. Even though KClO3 is what? What's KClO? Don't write it down. What is KClO3?
Potassium.
Look at the sheet. You got to look at the sheet. Potassium chlorate. So this guy ends in 8, even though he's got 3. This guy has 3, and he ends in 8 because it has to do with the root word. Compare your number here to the root word. Got it? All right, let's do a couple more. Actually, we're going to do quite a few more because that's all we're doing today. I'm going to give you the rest of the time at the end to get caught up. I know you guys probably didn't have as much time as the other class to get a lot of this homework done, and I am checking it tomorrow. So you might want to get working on this. So let's do the next one. FeNO42. Now, again, don't go crazy on me. Don't go doing stuff that I never told you to do. We're not going to use prefixes here, as in di or tri or tetra, right? But we do have to use, if it's a guy in the middle, Roman numerals, if it's one of those transition elements. Everybody get an answer. Put it down. See what you forget. If you can't do these today, you're going to have a hard time tomorrow on the quiz. What do you think, Jared? What'd you get?
I had iron pernitrate, and iron had a Roman numeral 1.
He has iron with a Roman numeral 1, per nitrate. Well, I agree with some of it. I'm not so sure about some other ones. Which part do you guys agree with?
Nitrate.
The per nitrate part is correct because it's got NO4, and the one on the sheet is NO3. That's one more than him. But is this iron 1 per nitrate? This guy has a -1 charge. So what charge must he have in order to lead 2 of them? +2. So that's iron 2 per nitrate. Got it?
The different, never mind.
Okay. All right. Let's try another one. Try some backwards. Magnesium bromate. Magnesium bromate. What would you do there? When we're doing backwards, you got to remember something. Bet you all have Mg for magnesium and BrO3 for bromate, right? Because it's the one on the sheet. But what do you also have to write? The charges. So I need 2 of those to balance them out. You see why? Because he's got a +2 for magnesium, and you know that because he's in group 2. And the bromate is -1, because you know that he's on the sheet at -1. See it on the sheet, -1? So I'll need 2 times -1. I'll need to balance those out. Number of electrons lost has to equal the number of electrons gained. All right? Try this one. Aluminum hypochromite. Aluminum hypochromite. If you can do this guy, you can do pretty much any of these type. Hope you all wrote Al for aluminum. I don't think anybody's going to get that wrong. Just look at the periodic table. Hypochromite, CrO what? 2, because the one on the sheet is CrO4. What else do I have to do? Charge it. +3 there, -2 there. That's a problem. Got 3, losing 3, gaining 2. I'm going to need a 2 there and a 3 there to balance them out. Let's do another one backwards the other way now. What about this guy? What is SO2 going to be? God bless you. SO2. If you're finding yourself writing hyposulfite, you can stop now. Because it's not. What is SO2, everybody? Sulfur dioxide. And that's exactly what you will do on the sheet tomorrow, on the quiz. This is why we do the review. It's why we did that big long one yesterday. Okay? Before I give you something I'm going to actually grade, we practice these, and you've probably done, if you'll have done all this homework. Oh, by the way, the homework, you say, well, what good is doing homework? I can't even see if it's right or wrong. Yes, you can. Every odd one up here, every odd number. And if you've ever noticed, I choose mostly the odd numbers. Every time and then I have to choose an even number because it has a problem on it that I want you to do. But look, most of these are odd. Every one of them has the answer in the back of the chapter. You can find it. All right, if you haven't realized that already, I've mentioned it a couple of times. That you'll have done, by the time tomorrow comes around, you'll have done probably 50 of these or more. Okay? Let's do one, maybe 2 more. How about this guy? Zinc phosphide. I purposely want to do one here for zinc because zinc is a weird guy.
Where is it?
Find them. If you try looking zinc up on the periodic table, you'll notice he is not in the main group. So you figure, okay, well maybe he's on the common ion sheet, and he is. But what I wanted to point out to you is, you notice what's not next to him? There's no Roman numeral next to him. Zinc, silver, there's a couple of others. They have that state so often they don't even put a Roman numeral next to them. Zinc's charge is what? Okay, you see him on the sheet at +2, under +2? Okay. All right, how do I finish that? Just P, right? Not PO1 or PO2. Phosphide, not phosphite. -3. So I need a 3 there and a 2 there. That is zinc phosphide. Okay. All right.